until here, the game ends, right? So this is how the reward works. So the game for this particular software agent, the reward is a victory in this game. How would this particular setup be represented in a typical supervised learning algorithm? You would do something like, okay, my first move, no result. Second move, I play a circle, I do a move, it's still a no result. You keep doing this. You enumerate all possible options until you come to a situation where, okay, now if I do this particular stuff, it's circle, right? So you would use something called a one-hot encoding for the entire grid, and you tell what each status, and you need to know what sort of moves are done. You do an entire enumeration, and you get what your results are. The reinforcement learning works slightly differently. You create just simple, you just tell them that if this happens, the game ends. That's it, right? So you just do the basic rules. And then you let them play with each other. And then when the game ends, one of them would have won, the other would have lost. So both bots learn a bit more than what they started with. They know that if I do these things, I get reward. And if I do these things, I don't get reward. So they know those things. And this keeps happening. So there are two phases in how this happens. One is the game play phase, and there's the learning phase. They're fairly similar for the first three things. You know where you are currently. Based on your current state, you know the list of possible moves. And for each move, there's a distribution associated with it. Based on the distribution of what moves can be done next, you make your next move. In the learning phase, it's again the same thing, just that once the game ends, you record the sequence of moves, and you go and update your distribution. So that's where the learning happens. So now you have an updated distribution, and so the next time you play, it gets selected based on that. All this is fine, but how does this translate into a sales cycle? An example would be in how an offer is made. So, okay. So when an offer is made, you want to know what kind of features need to get into that particular. So for example, the customer wants a TV. You really need to know what kind of features need to be in the TV which the customer would be most willing to buy. So you want to come up with some kind of strategy that jumpstarts that process, rather than, oh, okay, do you want this TV, do you want that TV? So instead of doing those negotiations, you want to jumpstart that process and start from there. And that's accomplished by reinforcement learning by a particular algorithm called a multi-armed bandit algorithm. So think about this as slot machines. So each slot machine has so it has a lever. If you pull it, it gives some reward out. So it has some distribution on how much money it can give, right? So now you have to make three decisions. You have to know, given this set of machines, which machines should I play, and what's the order in which I should play, and how many times should I play this machine? Okay, so these are the things that you would have to do, and that's solved by something called this is the multi-armed bandit problem, and there are very well-defined solutions on how this could be done using reinforcement learning. This is exactly what we do in sales too. We need to know which customers to talk to, what is the order in which, so I'm planning out my day, I have 8 hours, and I need to know what is the order in which I should call my customers. And how many times should I call each customer? So these are the things that exactly translates into the multi-armed bandit algorithm. And as I poke the customer, so you can keep doing. So what happens when you start doing it, right? So you don't have any information about the slots. You don't know how much money will come here, how much money will come from there. So you start getting more and more information. At some point, you have a better model of each of the machines, and you would use that to make decisions. And that's what happens here. So can we reduce the number of back and forth negotiations? So we would use active learning too, because once you talk, you know what the updated distribution is. You go and update your distribution. The challenge is you should come up with a warm start. The only challenge that cannot really be decided here is the time taken to close the deal versus the amount that comes from the deal. You wouldn't know if you can spend a little more time. So this is still a very hard problem to figure out. So if you spend a little more time, can you make much more money than what you would spend with another customer? That's what it does. In general, okay, these are the set of tools that we use to build a machine like this. It have a lot of components. Reinforcement learning is done in R and Python. Some backend data is in Hadoop. We use in-memory databases in MemSQL, VaultDB, and relation database in Postgres. Socket station called Airflow. It makes it repeatable on how the process can be done. And then just dashboard for the data scientists to show the team and get feedback, and then it gets into production using a Click or Tableau. So yeah, that's all. Yes.
So as I understand, the model is dependent on the query that you post to the customer.
Yes.
The responses that they give us.
Yes.
Those responses you may be feeding in some software or something, and then it would decide, okay, this is the best way to go forward. Right? But I don't think so it would work because most of the time customers will not answer you what you want. It is not like a normal question answer session like I'm asking you to answer. That person might not answer, or that person would answer something which he means something else and the words are something else. So this is a lot of, say, psychology involved, a lot of body language involved. How do you take care of those things?
So it depends on what. So it's not that it's going to happen. So it's not like, oh, I have a questionnaire and I'm calling the customer and I'm going to go over the questionnaire, right? So what generally happens is that some set of questions are given to the sales guys telling we need more information about the customer on these aspects. And then the sales guy will call. And then it will not happen through one call, but over multiple calls, you'll get some of those questions answered. You will never get all the data, right? So for example, right, okay, what do you do, what are you going to do with your existing device? Are you going to throw it away, or are you going to, so things that can really, so even for the data that you need, you rank order them telling this is more important because this can have more intuitive explanation later on to some things which may not have, for example, how much time do you spend on Facebook is not a relevant question, right? So things like, okay, but what do you do with your machine? Are you still using the machine that you bought with us 4 years back? So those are things that can have a lot more uses.
I hope the customers were so simple. I mean, normally in the real case scenarios, the information that you get might not be actually true also. So what the customer is telling you might not be true also. So in real life scenarios.
So the thing is, so you generally use. Okay, so you're not going to build tailor-made solution for every single customer, right? So your model, so what a machine learning model is, in some sense, a simplification of what the data scientist thinks the world reality is, right? So it's just, that's what it is. So you want something that works for most of your customers. So you keep doing this over multiple customers, and you believe and you hope that statistics helps you in normalizing. These might be just outliers. Yes, it's true that a lot of customers may not tell, but then that's what is the work of a salesperson. And also, your point is right, that I ask something, and then I might be misinterpreting what the customer is telling. So there's data entry problems. So data issues are always there, but this is just a framework on how it would work. And the advantage is this works with less amount of data. So if you want to go and label something, for example, a similar example to the security use case we saw before. If I want to know if the security is a real security threat or it was a fraudulent, it was just a alarm, but false alarm. So somebody still needs to go and tag all those things. So it's very expensive to go manually and tag all those instances. Yeah, so what, good question, right? So that is why, yes, so that's why we don't use reinforcement learning just with that, but we also use that along with active learning framework. So you don't do just reinforcement learning. So just reinforcement learning will not work with the data. And I'll answer that question a bit, but what we propose is to use active learning on top of that. So that helps in getting quicker feedback, and you can have a better model quality with a less amount of data. To generate data in reinforcement learning, what is typically done is you make the bots play with each other. So what would generally happen is I create personas of different salesperson, and I create them as bots, and using real data. So we'll run some testing framework, an automation testing framework, right? So then somebody from business will monitor that. They will start playing, telling it, oh, I'm going to offer this, will you buy? I'm going to offer this, will you buy? And this keeps going on, and somebody will give feedback, and that's used to make improvements to the model. So it plays with itself, it plays with each other, and you generate data to this. That's a very common framework on how reinforcement learning is done. This is fairly work in progress kind of stuff. So in general, I don't know how many of you have worked in B2B sales. The accuracy is generally very low. So you would want things which are directionally closer to what's better, and it's, yes.
In terms of the infrastructure on how you capture it, right? So you mentioned that there is this information that needs to come from the person who's actually selling. So how is it envisaged, or how is it captured?
Yeah, so the very common thing that's done is to write it as a, so there are two things that can be done. One is you can have your own app, which the user has to come and enter all the time. In general, big organizations use SFDC, and so you write an app on top of SFDC. So along with what they enter the deal or whatever, after they make a call, they need to make some bookkeeping entry. So it will be integrated with that app itself, and they need to add, so maybe few questions every time they make a call. So that happens.
Is that integrated with the traditional CRMs, or is it a separate? Because then there's too many entries, right?
Yeah. So anything that's done has to be integrated into the same workflow to get. So if you have a different application, uh, sellers don't go and enter the information, then you lose. It's mostly integrated with. So for example, almost SFDC is the most popular CRM right now, and that's generally used an app on that. It depends on what application is. So for reinforcement learning, the OpenAI gem that has Python binding, so you got to use that. It's really no reinforcement learning framework in R yet. TensorFlow also has a reinforcement learning library, but the OpenAI is much better than what is there in TensorFlow. But what we specifically use is multi-armed bandit, and that implementations are there in, I mean, that was invented in like 90s. So you have implementations in Java and almost any tool that you can think of.
Bargava, interesting talk. So one of the things which I learned from my boss, and he has an extensive experience in sales, he told me that there is a negative correlation in the number of meetings and the sales. So, the more meetings you do, the guy is not going to buy. Has that been an observation in your analysis? Or somewhere around that? It's okay if you don't want to answer.
No, I mean it's a very hard thing. For example, like at least for the business that I'm in, we don't have like really strong competitors across all the suite of products, right? So then there is some advantage that we have. So
You're already biased. Your data set is. Okay.
yes.
Yeah, well, sorry, asking
No, sure.
So you mentioned that in B2B,
No. So let's think about this way, right? So so traditional pitch. So there are companies. I don't know if you know. So there are companies like Lattice. All they do is that they help big B2B companies run sales plays. So campaigns for sales, right? So they just get data, they build models, and then they do that. The problem is that it doesn't account for the feedback that the customer has right now. So when you tell accuracy is not good, it's not like what accuracy you see in computer vision and human face recognition using deep learning. Similar things can't happen in B2B sales because it's more psychology driven and there's a lot more factors in play than so things like human face can work well because it's static. You cannot really cheat your face. But when I talk to someone on face, I can mean something, I can tell something. It's very difficult to make interpretations out of what that happens. I'll ask for a quote, and then I'll go for a vacation, and then something else happens. The company has budget freeze. You have so many other things for which you don't have control over. And at that time, any additional information that you can get can help improve the model's performance. So for example, the way it would be used is, so for example, this customer, I have a prioritization list, and the customer, I'm asking the seller to call this particular customer tomorrow morning. He calls, and then he figures out that they have budget constraints, so he goes and enters that. The model updates, and the next day,